Dear learners, welcome to the session on simulation of robotic kinematic analysis. In this video, I will demonstrate the kinematic analysis of 2DOF manipulator using a robo analyzer software. Robo analyzer is a user-friendly software designed to simulate the kinematics and dynamics of robotic manipulators. It is a 3D model based software that can be used to teach and learn the robotic concepts. The need for the robotics software to teach the robotics effectively has motivated the robotics team of IIT Delhi to develop this software called Robo Analyzer. Its development started in 2009 at the Mechatronics Lab, Department of Mechanical Engineering at IIT Delhi, under the guidance of Professor S.K. Saha in order to support the learning and teaching of the topics covered in his book Introduction to Robotics, published by Tata McGraw-Hill, New Delhi. Now, the Robo Analyzer version 8.0 and above is available with an exclusive license package. Now, let us explore the use of Robo Analyzer software for kinematic analysis of 2D of robotic manipulator. Enable this Robo Analyzer. Once you get it, the Robo Analyzer window will be opened. On this, you can observe that there will be different possible menus. There will be a file. Under the file, you have a new, open, save kind of things, and help, feedback, and other details will be there on the top of the ribbon. In the bottom of it, you have an option for selecting the degree of freedom, that is the number of joints it can have. So, it ranges from 1 to 7. Now, we can select it as 2, as we are going for a simulation of 2 degree of freedom manipulator. Here the next one is selection of the robo. Either the robo joints could be of prismatic or rotary in nature. Prismatic means is a linear joints, whereas the R represents rotary joints. In our case, consider that we are going for 2 rotary joints in our case. So, we will be selecting as a 2R. Once you select it, then enable the load selected robo. On enabling this, you will get on the screen, you will get the workspace, a 2D robo manipulator will be available. So, in this case, we will be selecting the robo for our use. After that, we need to set the joint limits and the joint information. As it has 2 joints available here, the joint 1, that is what it is now enabled. You can see that it is in the yellow in color. The joint type is labeled as revolute, and also the joint 2 also it has been made to a revolute. Further, we can have other details whatever provided on this area will be chosen appropriately. As a part of our initial simulation, we will be avoiding the joint offset now, and followed by, you can see in under the joint angle, it is labeled as variable. It means that it is a joint is a rotary in nature, followed by, and the adjacent way you have a link length. It is specified in terms of meters in this case. For this robo is concerned, it has been given that the link 1 is 0.2 meters. Similarly, the joint 2 will also has a 0.2 meters as a default condition. If you are interested in, you can change these values to 0.1 also. Once it has been done, there is a change in the you can see that the changes observed on the workspace, followed by the twist angle. As I said, it is an initial simulation. We are not enabling the twist angle on both the joints. Followed by, there is 2 values you can observe, that is called initial value and the final value. The initial value, it will be determined by degree or meter. Since it is going to be the joint is rotary in nature, it will be specified in terms of degree. Now, the initial degree is 0, the final position is 180 degree. This is meant for joint 1. Similarly, there will be a joint 2 will have a 0 degree and the final is 90 degree. Now all set here. It is describes the how the robo configuration is all about. The number of joints, what are the parameters, it has been set. Once it has been set, the next step is moving to the right top corner where you have an information about the analysis. In this case, it has been given that the time snaps and the number of steps available here. Here you can see that there is a 4 kinds of options available. There is an Fkin represents forward kinematics, Ikin represents inverse kinematics, Idyn represents inverse dynamics, and Fdyn represents forward dynamics. Now we are going to see that how the forward kinematics works. Enable this forward kinematics. The analysis is complete. This is visible now. Once this analysis is complete, notification is received. This the button, the playback buttons are available now. Let us try. Now it is meant to be play forward. By clicking this play forward, you can observe that the robo starts moving and it takes its own position from the initial to the final position. If you want to see that in a backward also, you can click on play backward. So, you will try to find out the motions of robo under the different directions. Once you have done this, this represents that the trajectory in which the robo end effector travels on. This is the way in which we can identify the robo motions for the given the joint values. In order to get more information about this, there is a tab called graph on the right extreme. In order to predict that joint information, click on the joint one. You will see that multiple option. In this represents that joint value represents the displacement, joint velocity as well as joint acceleration. Similarly, you can select over joint 2 also. You can start comparing their behavior based on the joint acceleration, how there is some changes on the acceleration part. Similarly, the joint value component. You can observe that first joint makes an 180-degree rotation and the second is makes an 90-degree rotation. This is easily visible on this graphical representation. Followed by you can compare the velocities as well. So, these velocities based on the displacement and the time, the change in the robo motion will be controlled by joint velocity also. By changing the data in these joint values and the robo configuration, we can able to analyze the robo behavior under different motions. In this, we have seen that how the simulation is effective in understanding the concepts of kinematic analysis of a 2 DOF robotic manipulator. This will makes you to learn much better and looking forward to see more number of analysis. Wish you a happy learning.